Have you ever gotten software to work on your machine but had issues getting it to run somewhere else? Today I'll be introducing an awesome tool called Docker that'll help you with this problem, and hopefully much more. Throughout these tutorials I'm going to be going over what Docker is and how you can use it to help your application development. These tutorials will hopefully give you a much better sense of how and when to use Docker. So what is Docker anyways? If you look on Wikipedia for the answer, you may get an answer like this. Docker is a set of platform-as-a-service products that use OS-level virtualization to deliver software and packages called containers. So what does that mean exactly? Well, let's think of what software is like without Docker. At the lowest layer, you have your hardware, and on top of your hardware, you have your operating system that talks to the hardware. Then above that, you have several binaries and libraries that your applications use to talk to the operating system. Then at the highest level, you have your applications. Notice here how the binaries and libraries that your application will use is available for all applications. This may normally not seem like a big deal, and in some cases this can even be beneficial. Consider the case where application C requires library dependencies from application A and B. You just save yourself additional disk space since you were able to completely reuse dependencies from application A and B. However, things get a little bit more complicated when you need to, let's say, get application C running on another machine. Which libraries do you install? To you, it seemed like application C didn't even need any dependencies. I mean, you didn't even need to download extra binaries or libraries to get application C working. So how do you know which ones you need? And this is one of the main reasons why software works on one machine and not another. It's because over time, several libraries and binaries can accumulate on a specific machine and you no longer know which applications require which dependencies. Not being able to have reproducibility when developing applications, especially when you're on a software team working with other developers, can significantly slow progress. Wouldn't it be great if we could somehow tie the dependencies to the applications you're developing for? This is where Docker really shines. Docker allows you to virtually isolate all your applications with its dependencies. Although your system can normally reuse similar binaries and libraries for other applications without Docker, it is often well worth the trade-off to have this isolation. Not only are you making sure that applications will always be packaged with its dependencies, but developing with Docker encourages developers to have better design practices by writing smaller and more manageable applications. Instead of being broad and just saying libraries, binaries, and dependencies, let's give an actual example. Let's say there are 3 different containers that are being developed. A container that is responsible for performing image processing via some camera over Ethernet, another container that is a web application, and a third container that is a graphic user interface, or GUI. Notice how the libraries and binaries include things like Ubuntu, Python, OpenCV, and so on. These are the types of things that you'll be including in your containers so that your application will be able to function properly. In these tutorials, we will be using Ubuntu as a base image in the container, as well as Python and Python libraries, but Docker containers are not limited to just these software packages. You can use Fedora, CentOS, Windows, and a lot more as a base for your container, along with a wide variety of libraries and binaries. Now let's say that we have 2 software developers, Sam and Bill. Sam was tasked to work on the image processing application, and Bill was tasked to work with the GUI application. Gary, a new software developer, comes along and wants to see and execute Sam and Bill's applications to get a better idea of what the team has developed so far. Sam and Bill gives Gary their containers, and Gary is able to execute their applications with a single command. The only thing Gary needed to have installed on his system is Docker, and he was able to launch Sam and Bill's applications. So developing isolated containers is great and everything, but what if you want to have the applications talk to each other in separate containers? Let's say you have 2 containers on the same computer. If you want to get application A to talk to application B, there are 2 primary options. You can either use sockets, or you can use a virtual mount. I will go more in depth on these 2 topics in a later video. For now, it'll just be enough to know that sockets and virtual mounting are the 2 primary ways to get applications in separate containers to communicate. If, however, you want to get applications that are on separate computers in their own containers to communicate, the primary way to do this is with sockets. So let's do a live example where I show you how to actually spin up a container. We will start with Ubuntu as a base image for this container. The command you need to run to get access to the Ubuntu bash shell is docker run-it ubuntu : the version of Ubuntu that you want, and then the program that you want to execute that's inside of the Ubuntu container. The -i just means you intend on interacting with the container, and the -t just means that the container will receive input from your keyboard and the container will push out output text from the container to the shell you're in. So an example would be docker run-it ubuntu : latest bash for spinning up a container that would be the latest Ubuntu version and running bash shell that you can connect to and interact with from your host machine. This command is the same thing as docker run-it ubuntu. Whenever you don't include the version number, it'll just default to the latest, and whenever you don't specify a command to run for the container, it'll be whatever the default command is for the image that you're spinning up, which is the latest Ubuntu image in this case. For the Ubuntu base images, the default command will be bash. Another example here is spinning up a container with the Ubuntu 18.04 image and running bash. Let's show this command in action. So before I show you any Docker commands, this is where I went to get the Docker installation executable for my Windows operating system. You can do the same if you're on Mac. For Linux, you can install Docker through a package manager like apt. There are several tutorials out there on how to install Docker on your system, so I'm not going to go through the details here. So after you install Docker on your system, one of the most common commands that I use is docker images. What that will do is it will show you any images or base images that you've pulled down to start a container. Another one that I commonly use is docker ps, which tells you what containers that you have spun up. Another one is docker ps-a, which basically tells you not only what containers you have currently spun up and running, but how many containers you just have in general, so even ones that are not running. So let's go over that first command, which is docker run-it ubuntu. It's not able to find the image, so it's going to pull it from the Docker repositories. And here you can see I'm in a Ubuntu container using bash. I can do ls, and you can see that this is the root file system of Ubuntu. I can do uname -a, and it tells you that I'm on Linux. If I were to open a new command window, and looked at my containers, you would see that I have a container up and running, and it was created 38 seconds ago. You can also see, if I run docker images, that I have an Ubuntu image, because that's what I pulled down. The name here is just a random name that was given to the container whenever you spin up a container and you don't specify a name. We'll go over later how you can specify names for containers so that if you have more than one Ubuntu container, you can name them. So now let's try getting a Ubuntu container that is 18.04. You can see that it doesn't have that image on this computer, so it's going to pull that down from the Docker repositories, and now I'm running it. So I can get out of this by doing exit. If I do docker images, you can see that there's two images now. One is the latest Ubuntu and the other one is Ubuntu 18.04. If I just do normal docker ps, you can see I still have that other one still up and running. If I do docker ps-a, you can see that I had a container that was up and running with Ubuntu 18 seconds ago. And let's say that, the container's still there, it's on your system, it's just not on or running right now. If I want to get it back up and running, I can do something like this, where I do docker start -i, and then the name of the container that I want to get up and running. And now I'm back in the container. It's also possible to stop containers. I just showed you that I could stop it just by running exit here. But instead of me doing that, I can open up another shell, or let's do exit here, and then let's kill the other container that we have running through the PowerShell here. So we can do docker stop the name of the container, then we can do docker ps -a, and you can see both the containers are stopped. If you want to remove these, we can just do docker remove and then the name of the container. Now if you do docker ps-a, that container is no longer there anymore, but you still see the images that were used to create that container. So you can spin up as many containers as you want from images and put your own software on there, you apt-get install and so on. If you want to remove the images, you would do something similar, except RMI for remove image, and then you would do Ubuntu, and then if there's a tag or version number like 18.04, you can specify here. So this is actually interesting to note that if you try to remove a image that is currently running in a container, or you have a container that's not running but it's still active, like this, you can see that it used Ubuntu 18.04 to run that container. So because I have a container that uses that image, that's why I'm not able to remove this particular image. Now, because I don't have any containers running the latest Ubuntu, or just specifying it with Ubuntu because it will tag on the latest word if you don't put anything, then this one will work. So it will delete the image. Now if we do Docker images, you can see that the latest one was deleted. And then I'll do the same thing for this container as well, so that we can get rid of this image. Ubuntu 18.04. And then we don't have anything left. So now we have a clean slate. So here are some of the commands that we just went over. You can use this as a reference. We'll be learning a lot more in future videos. So I would quickly like to recap some of the things that we went over in this video just to summarize. So we went over how Docker tightly integrates applications with their dependencies in an isolated environment called a container. We went over how Docker containers can help ensure reproducibility when executed. These containers can be easily shared and executed by other developers. And we went over how applications in containers can communicate to other applications in containers by virtual mounting or by sockets. And we showed how to use Docker to get access to an isolated Ubuntu bash shell. We also showed how to see what images are downloaded and what containers are running or not. And we showed how to start back up a non-running container, and also how to remove containers and images. So thank you guys for taking the time to watch this video. I will be making a couple of other videos on this, so stay tuned. Thank you.